Let's imagine this is a hypothetical situation. A U.S. administration led by Trump orders a nuclear bomb test. What would happen right away, to whom, and how would it play out legally and politically? Two likely ways: an underground test at the Nevada National Security Site, legal under U.S. law but controversial, and an atmospheric test, which is widely banned and condemned worldwide. On command, the DOE, NNSA, and DoD would activate the site, lock down the area, issue a NOTAM and restrict airspace, and prepare seismic and radiation monitoring. If underground, they'd drill a shaft, place the device, and seal it for containment. An earthquake would be expected nearby. Off-site dose would be low if there's no venting. If atmospheric, global condemnation is almost certain, it goes against the norm set by the LTBT and reinforced by the CTBT norm. There are high risks of fallout, shockwave, and EMP. For people near the site, road closures and shelter-in-place advisories. Underground, low off-site exposure. Atmospheric, possible evacuation and medical monitoring. For the environment, underground, a subsidence crater and a contaminated cavity below. Atmospheric, widespread fallout carried by the wind, lingering on land and water. In diplomacy, emergency discussions at the UN, strong statements from allies, rivals would use it for propaganda. The CTBT norm would be broken and NPT review dynamics would be chaotic. In the markets, risk aversion would increase, gold and U.S. treasuries might go up, equities and emerging markets might get shaky, defense stocks could rise. Global security response, nuclear states would go on alert, satellites would orbit for plume and thermal data, and seismic networks would release magnitude and estimated yield. In the next hours to days, press briefings, radiation sampling, and legal challenges. Whether underground or atmospheric, expect intense oversight and international inspections. Reminder, this scenario is hypothetical. Our goal is to explain the two paths, underground versus atmospheric, and the immediate effects on people, the environment, diplomacy, and the markets. Historically, the United States conducted hundreds of nuclear tests, then imposed a unilateral moratorium in the early 1990s. Since then, only non-explosive evaluations continue, while the memory of the desert proving ground still lingers. If an order came today, two paths loom: an underground shot at the Nevada National Security Site, or, far less likely and widely condemned, an atmospheric detonation at a remote range. Treaty posture. The U.S. signed the CTBT but never ratified it. The norm still discourages testing. The Limited Test Ban Treaty bans atmospheric tests, making any above-ground shot a diplomatic firestorm. Domestic authorities, DOE and NNSA, lead test readiness with the DoD and support, activating plans, labs, and site crews understanding directives and test readiness protocols. First moves are mechanical and immediate. Airspace restrictions, NOTAMs, roadblocks, perimeters, and pre-positioned seismic arrays. Quiet signals that something serious is in motion. Underground path, drill and case the shaft, install diagnostics, lower the device, then stem and seal, containment by design, with sensors primed for any hint of venting. Atmospheric path, a remote range, specialized platforms, weather windows, and a global backlash, because fallout, shockwaves, and EMP risk international lines very fast. Monitoring lights up, seismic networks, infrasound arrays, radionuclide samplers, and satellite eyes, ready to catch the signature within minutes to hours. Inside the chain, field teams, laboratories, and command posts sync up, DOE, NNSA leads, DoD coordinates, and Homeland and environmental agencies stage for sampling and briefings. Why test at all? Signaling, validation, and stockpile confidence, but in a world primed for miscalculation, even a contained shot can tip rivals to higher alert. Metrics and monitoring would be relentless. Seismic magnitude, containment assurance, plume models, and the diplomatic shockwaves measured in statements and sanctions talk. The risk hinges on the details: yield, geology, weather, and test type, underground, subcritical, or atmospheric, shape, exposure, and escalation. The higher the yield and poorer the conditions, the faster events outrun control. The operational arc is simple: plan, authorize, conduct, assess, tight, go, no-go gates, auditable data, and immediate sampling to confirm what really happened. Around the site, alerts and advisories stand ready. Shelter in place for underground anomalies, evacuation and medical monitoring if an atmospheric release is suspected. This remains a hypothetical, but the stakes are real. One sealed shaft in the desert, and the world holding its breath for what follows. The order's in. Staging goes live. Mark the ground, cordon the pad, bring up the containers, blast doors sealed, badges checked, lights down to red in the control room, equipment racks roll out, power, telemetry, and explosive diagnostics laid in neat loops. Baselines are logged before anything armed gets near the shaft. Perimeter cones mark the sterile zone. From here on, every step is scripted, witnessed, and time-stamped. Lock down the rings, hot, warm, cold zones set, access lists printed, siren test window posted, range roads close, no exceptions. Containment shaft, torque checks on a sealed, non-identifiable container, tamper seals verified, arming plugs secured, QA initials on every tag before the lower. Dry run countdown, comms, power, sensors, firing chain, and fail-safe abort lines. Clocks sync to the second, UTC on the wall, eyes on the waveform. Evacuation perimeters go live. Muster rolls read back on radio. All accounted. Drills run until the paths are muscle memory. Agencies and EOCs stand to. Police, fire, medical, hazmat. Siren test verified. Final med bay and decon set. Waiting and quiet. International monitoring prep. Seismic arrays queued. Data sharing links primed. Any tremor, any plume, push to allies in minutes. Containment first, negative pressure tunnels, HEPA and scrubber stacks humming, fallback grout plugs ready, if a leak so much as whispers. Airflow checks, manometers steady, filters green, gas capture routes mapped. Every valve has a hand on it. Weatherboard lights up, plume models, exclusion lines, NOTAM and hazard beacons, contingencies if the plan changes, final go, no-go, engineering green, safety green, legal green, public comms ready, radio chatter tightens, ground shutters, breath holds, T- begins, 10, 9, eyes on the board, any fault and we abort, no fault, and we fly. Sirens and SMS tests fire, the last sweep clears the range. Teams brace for post-shot diagnostics, T-, single digits. Stand by. To know if a nuclear blast happened, the world fuses 4 signals: seismic quakes, infrasound shock fronts, radionuclide fingerprints, and satellite eyes. Layer them fast, cross-check hard, not a hunch, proof. Seismic first, P&S waves light up stations, location snaps into place, and magnitude converts to an estimated yield. Depth phases separate explosions from quakes, automatic alerts in minutes. Infrasound catches the shock front, micro-pressure waves that travel for thousands of kilometers. Array bearings and arrival times triangulate the source and suggest an atmospheric or surface component. Radionuclides tell the tale. High-volume air samplers and noble gas systems hunt fission xenon, Z133, Z135, and isotopic ratios that point to a bomb. Gamma spectra, custody seals, lab QA. Results in days. Satellites confirm the scene. Optical, radar, and thermal spot hot plumes, dust fans, fresh cracks, and subsidence craters after underground shots. Before-after imagery appears within hours to days. This is the CTBTO's International Monitoring System, seismic, infrasound, hydroacoustic, and radionuclide stations feeding the data center in Vienna. Global arcs converge, preliminary products roll out quickly. In parallel, national labs recompute, local seismic arrays, weather-backed trajectories, independent radionuclide checks, open-source satellite passes, everything cross-validated for consistency. What the public sees fast: origin time and coordinates, magnitude and inferred yield, waveform plots, and alert bulletins. Auto notices in minutes, reviewed summaries within hours. Typical clock, detection in minutes, analyst review in hours to a day, radionuclide confirmation in days to weeks, with models tracing the source back through wind fields. Field work stays clinical: high-volume filters, portable collectors, and occasional aircraft sniffer flights. Tight chain of custody from sampling to lab bench. No ambiguity, no leaks. When seismic, infrasound, xenon ratios, and satellite craters line up, doubt collapses. The signature screams nuclear, and attribution grows sharper with every data layer. Still, beware lookalikes, earthquakes, mine blasts, industrial vents. That's why multi-sensor fusion and expert review matter before the world declares what happened. Once the evidence aligns, findings go to states, who speak officially. Technical feeds and records stay open for researchers and the public to verify. That is how we tell the truth at speed. Sensors, open logs, repeated checks, minutes to hours for detection, days for isotopes, enough to quiet rumors or confirm a terrifying fact. Radical transparency means a public nuclear risk dashboard. Live dose rates, USVH, count per minute trends, and water sample results from every station, plus clear baselines, thresholds, and what a rising counter really means. Each reading is time-stamped, mapped, and compared to normal for your neighborhood, so spikes stand out fast. The goal is clarity under pressure, simple numbers, trend arrows, and a plain language note on what to do next. Color codes guide action. Green is normal, yellow means heightened watch. Orange is shelter in place, close windows, switch HVAC to off, recirculate, use a well-sealed room. Red, if ordered, is a calm, staged evacuation along posted routes. Push alerts mirror the site. Phones, sirens, and kiosks update the moment levels change. Live maps layer wind vectors, plume forecasts, and isodose bands, so you can see the likely path, ETA by block, and when conditions improve. We publish reliability metrics, sensor uptime and last calibration, alert latency from reading to warning, lab turnaround on radionuclides, and data completeness per zone. Transparency isn't a headline, it's a scoreboard that never turns off. Citizens can file reports with photos and locations. FOI requests and media uploads are tracked. APIs expose CSV JSON so anyone can analyze the data. Kiosks and SMS mirror the dashboard. When orange or red is triggered, guidance appears instantly. Journalists, academics, and community groups get open tools, versioned methods, and archived data sets to explain readings, plume behavior, and why alerts change. On your phone or the neighborhood kiosk, you'll see current dose, wind direction, plume ETA, and the recommended action. Orange, shelter in place, seal gaps, limit time outside. Red, by order, proceed to assigned route and muster point. Maps highlight safe corridors and monitored reception areas, updated in real time. Analysis spots hotspots and wind shifts, checks message delivery, and issues a daily situation report, plume overlays, deposition estimates, and any changes to guidance. From fear to informed action, verified alerts, clear steps, and steady updates build trust and resilience. Communities get stronger when the facts are visible and the next move is simple. Make transparency the default. Live dashboards, audit trails, open logs, and explicit evacuation triggers like sustained red for 2 intervals, plume head within a set buffer, or lab-confirmed gamma Chuck xenon release. The journey begins with public data and calm guidance, while protecting whistleblowers and data users who hold us to account. When conditions turn radioactive or contaminated, protection comes first. Crew, first responders, and neighbors. We lock down access, stand up decontamination corridors, and enforce respirators and full PPE at the perimeter. Every shift, not just during inspections. Entry control is strict, color-coded zones, posted dose limits, dosimeter pickup and 0 checks at the gate, and a short safety brief. Only trained, medically cleared personnel proceed beyond the checkpoint. In the donning line, suit up with coveralls, gloves, boots, and respirators. Buddy checks for seals and fit. Barcode issue of PPE so replacements and end of life are tracked. Medical monitoring runs all day. A mobile clinic logs vitals, baseline ECG and SpO2 as needed, heat stress screens, hydration checks, and rest cycles, before, during, and after shifts. Prolonged emergencies strain the mind. A quiet counseling tent offers private check-ins, peer support, and calm spaces, plus family call stations to ease anxiety and keep teams steady. After work or potential exposure, crews move through decon, rinse, scrub, and survey, then clean clothes, bagged waste, and transport to rest areas. Nearby residents get calm guidance, shelter-in-place tips, and essentials if relocation is ordered. Standard drills keep motion smooth, muster points, badge scans, controlled entry and exit, and live logs tied to permit to work, so command knows who is where and for how long. For neighbors, protection is clear and visible. Exclusion fences with red strobes at night, air sampling trailers, and simple guidance. When to seal windows, when to mask, and where to get water tested or medical checks. Thresholds are posted and public. Real-time dose maps, action levels for stay indoors versus evacuation, KI distribution protocols if advised, and on-site compliance audits to keep standards tight. Each shift ends with a short debrief, near-miss reports, PPE issues, hydration and fatigue notes, and updates to procedures, so tomorrow is safer than today. With PPE and respirators, access control, decon lines, medical monitoring, and mental health support working together, crews stay protected, and so do the families living nearby. Truth requires action. Within minutes of a nuclear test, executives sign emergency orders, disaster declarations, curfews, and movement controls, so response teams can act fast and lawfully. Aviation first, NOTAMs and temporary flight restrictions lock down airspace. Satellites and patrols track the plume, while restricted corridors protect search and response flights. Declarations follow. A governor requests federal support. The president issues an emergency or major disaster declaration. State and local emergency operations centers go to full activation. Evacuation orders define hot, warm, and cold zones. Contraflow plans kick in. Roadblocks and checkpoints create safe corridors. Highways empty to move people and assets. Command and control shift to unified command under ICS. Federal, state, and local leads align objectives. The Joint Information Center pushes one message. EOC screens track evacuation corridors in real time. Interstate coordination ramps up through EMAC. Mutual aid engines, hazmat, and public health teams cross borders. Helicopters patrol restricted zones and support medevac and sampling ops. Legal authority underpins every move. Evacuation and curfew powers, price gouging bans, and liability frameworks for injuries and property loss, documented for later claims and audits. Environmental rules adapt in emergencies, expedited reviews, clean air waivers for life-saving ops, and CERCLA-style authorities for contamination control, while sampling keeps chain of custody intact. Internationally, An atmospheric test triggers legal blowback, CTBT norm violations, UN debates, and potential sanctions, so foreign affairs and defense coordinate statements and evidence, enforcement on the ground, perimeter security, penalties for unlawful re-entry, and civil liberties safeguards, time-bound orders, public logs, and independent observers to keep trust. From truth to action, orders signed, skies closed, corridors cleared, and teams synchronized, documented every hour until monitoring says it's safe and the all-clear is given. At first light, agencies mobilize, briefings at dawn, roles assigned, and a unified incident command. The goal is simple: protect people fast, coordinate resources, and keep information flowing. We trigger a staffing surge, activate rosters, call in mutual aid partners, stand up 24/7 shifts, and onboard temps and retired specialists for radiation safety, logistics, and shelter ops. Rapid radiation safety training rolls out, time-distance shielding basics, dosimeter use, contamination control, and proper PPE donning and doffing, validated with short competency checks. Mass PPE distribution begins, respirators fit tested, Tyvek suits issued, gloves and eye protection staged, tracked with e-logs and badge scans at controlled entry points. Decon teams drill in stadium shelters, dry and wet decon lines, bag and tag procedures, runoff control and waste manifests, rehearsed until timing and safety hit targets. Technicians fan out to rooftops to install air samplers and high-volume filters, while field crews deploy portable stations and groundwater monitoring wells with strict chain of custody. Labs expand capacity, surge staffing, mobile lab trailers, validated methods for alpha, beta, and gamma spectroscopy, and dashboards for turnaround time, throughput, and quality control flags. Transportation ops stage buses for evacuations, pre-planned routes, ADA accessibility, priority boarding lists, and radio check-ins at each waypoint to keep flows calm and orderly. Safe shelter management kicks in, registration and triage, clean air rooms with HEPA units, isolation spaces, potable water points, and steady updates pushed to residents' phones. Public communication stays constant. Color-coded alerts, real-time dose maps, hotline and SMS blasts, and community liaison teams to translate guidance and counter rumors quickly. Readiness is a cycle: brief, equip, train, monitor, shelter, then review and improve. The public sees the metrics, and agencies are accountable for every step. In a crisis, procurement becomes emergency logistics. We need sensors, PPE filters, iodine tablets, shelters, cleanup crews, and lab reagents. Fast, open, and trackable from purchase order to delivery. One e-procurement portal for all agencies and LGUs, rapid contracting windows for sensors, shelter kits, cleanup services and reagents, so every bid and award is in one place. Use time-stamped digital RFQs and e-signatures, auto-recorded bid openings, and immutable public logs, so every step has a verifiable audit trail. Total transparency. Terms of reference for sensors and filters, calibration and chain of custody plans, delivery SLAs, and live plus recorded bid openings, published by default. On the portal, itemized lots, delivery schedules, QR-coded manifests, meeting minutes, the winner, final price, and the reason for award, so the public can follow every shipment. Show true ownership. Map beneficial owners of suppliers, labs, and haulers to catch conflicts, shared control, and cartel patterns before awards. Strengthen competition and standards, limit negotiated deals, require filter and sensor specs, calibration certificates, and standard chain of custody for all materials. At the gate, scan every pallet, QR tags, weighbridge receipts, and photo proof, cross-checked against open ownership data, with zero tolerance for bribes or price fixing. Pay only for verified milestones, sensors installed and reporting live, shelters stocked and inspected, lab samples processed with results, and cleanup volumes measured on site. Let the public help. Report late deliveries or damaged goods with geotagged photos, track ticket status on the portal, and trigger audits when thresholds are missed. With clean, digital, interagency logistics, life-saving goods move faster and safer, while we save billions and deliver the sensors, cleanup, and lab capacity people paid for. Change starts from the ground up. At village halls, neighbors learn to read plume maps and alert colors, practice calm drills, and assign roles before sealing doors and vents when advisories say so. Youth brigades lead setup, placing portable HEPA units in shared rooms, taping window gaps, and checking the dashboard's wind arrows to guide safe indoor spots. Hold short trainings, how to read plume direction and dose legends, assemble a go bag, water, masks, meds, flashlight, and when to seal a room versus when to just close windows. Use simple reporting guides. Hotspot today, risk tomorrow. Open the app, confirm your GPS, follow the prompts, and submit clean details only after checking with official advisories. Make data personal. Dashboards show plume paths and status colors. If it flips from green to orange, seal one room, set the HEPA running, and check on vulnerable neighbors. How to send a location-tagged report, turn on GPS, snap a geotagged photo or short video of the hotspot, add time and a brief note, then upload. No rumors, just facts. Support the vulnerable, pair youth with homeowners to check on seniors, deliver masks, and help seal a clean room. Log every visit in the app for follow-up. Post progress boards and local dashboards, roles, routes, and alert levels, kept side by side with plume maps and a quick guide for sealing rooms and safe muster points. Apply a 72-hour follow-up. Log, verify, escalate. Update boards to reported, in progress, resolved with timestamps and the office in charge, so nothing falls through. Celebrate honest reporting and practice rumor control. Share verified updates at town halls, correct mistakes politely, and link every claim to a source. In a prepared, informed culture, every village has a bulletin board and a digital dashboard. Calm steps, accurate reports, sealed rooms when needed, and neighbors helping neighbors. Breaking news. A Trump-ordered nuclear test, whether atmospheric or underground, triggers instant condemnation. Capitals convene crisis calls, warnings go out, and allies and rivals alike urge restraint to prevent rapid escalation. First wave, diplomatic demarches, formal notes, summoning ambassadors, and joint statements from blocs like ASEAN, the EU, and NATO, calling for verification, restraint, and immediate transparency. Embassies coordinate messaging, align talking points, and prepare contingency briefings as partners seek a common line to lower tensions. Even amid rivalry, back channels reopen, signals that deconfliction must outrun outrage. The UN moves fast. Emergency sessions table a resolution, fact-finding access, cooperation with monitors, and steps to halt further testing, while keeping doors open for talks. Sanctions talk begins, targeted designations, export controls, and travel bans, anchored to evidence, verification triggers, and clear review timelines. Lawyers frame the legal basis, diplomats weigh costs against the need to deter repeat tests, cooperative monitoring spins up, CTBTO stations, national labs, satellites, and aircraft samplers share data to confirm signatures and model any plume and fallout. Allied task forces stand up, synchronized briefings, intel fusion cells, and contingency plans if the crisis widens. Safety first, NOTAMs and maritime warnings reroute traffic, define exclusion zones, and activate deconfliction hotlines to prevent accidents in air and sea lanes. Risk rises, alert levels tick up, miscalculation looms, and talk of military buildups feeds an arms race spiral, another reason to pause and step back. Every escalation raises costs, fear, and the chance of an incident. De-escalation tools, pre-notification of activities, observer access, verification windows, and a freeze on high-risk tests, paired with hotlines that stay warm, not symbolic. Confidence-building measures buy time and lower the odds of a mistake. Regional partners, including the Philippines, press a firm, evidence-led stance at the UN, in ASEAN, and in technical forums centered on public safety and stability. The message: uphold norms, share data, and keep channels open. Balance is the anchor, principled but pragmatic, fast with facts, and relentless on deconfliction to reduce risk and protect the global public. Real change takes years. Map contaminated soils, set groundwater baselines, and keep sampling the air, so we know what was there, what moved, and what still lingers. It's a connected system, monitoring wells, flow maps, and lab quality control that track groundwater plumes and hotspots season after season. Consequences accumulate, radionuclides and heavy metals bioaccumulate in crops, fish, and wildlife. Food chains and rural livelihoods feel it first. Health follows environment. Registries and epidemiological studies track cancers, thyroid disease, and developmental outcomes. Hospitals log exposures across long latencies. Cleanup must meet standards: soil excavation or capping, pump and treat, and long-term stewardship, under clear action levels, chain of custody, and public audits. Underground versus atmospheric: contained shots leave a sealed cavity and localized crater. Risk rises only if there's venting. Atmospheric tests spread fallout on winds and rain, crossing borders and generations. Governance locks it in: precautionary thresholds, real-time disclosure, independent split sample testing, and enforceable cleanup and monitoring plans in law. Build institutions, not heroics. Accredited labs and river basin authorities with citizen oversight, standard methods, and open yearly reports. With discipline, risks shrink over years. Remediated sites, safer water, and resilient green-blue projects, if data and accountability never stop. Public office is a trust. Decisions must protect children, farmers, and fishers first, and be traceable from sensor reading to response. Final truth: some damage cannot be undone. Choose containment over dispersion, science over spectacle, and vigilance over denial, or live with irreversible loss.